There are a number of different file formats and types that can be used for multimedia. We're going to take a look and discuss a couple of them here. All right, we can look at files in a number of different ways. And one of those ways is to whether or not they are either bitmapped or vector based. With a bitmapped image, the image is made up of pixels. So if we simply colored these pixels different colors, we can form an image. So when we store a bitmapped image, we are storing data corresponding to the color of each one of those pixels that's then going to make up whatever image we happen to have. If we've scanned a photograph, it's more than likely going to have been a bitmapped image. That image then is a series of pixels, and whatever color that pixel needs to be in that particular location, that's going to represent that image. Now that differs from vector-based images. Vector-based images typically are more of a solid color type of shape or image. However, the shape is not represented by a series of pixels, but rather it's a mathematical description of that image. What that does for us is allow for very small file sizes. It also allows us to be able to scale without any problem. What I mean by that, if you take a photograph, which is a bitmapped image, and you enlarge it and you enlarge it and you enlarge it, you start to see the fuzziness, the muddiness in that image more than likely because those pixels are being enlarged and enlarged and enlarged. You're not adding any more detail to that image. Whereas if I were to take some solid colored shape that was vector based, I could enlarge this 10 times, 100 times, 1,000 times, and the edges are going to be as crisp as they were when they were much smaller. Because mathematically that shape continues to be regenerated and regenerated no matter what scale I have. So vector-based image is very good for different shapes, but we're looking at not photographic type images, we're looking at areas of solid color in most cases. Very good for scaling purposes, very good for keeping the file size small. Bitmapped, we're looking primarily for continuous tone type of images such as photographs. Now that doesn't mean to say that we can't use a bitmap for something that is a shape that is solid color. However, it does mean that as we enlarge that image, we're going to see the pixels associated with that, and we can get a ragged edge around that image. All right, we can also categorize images based on their compression, and we're talking here primarily with the bitmap types of images. So we can have lossless file formats, and we can have lossy file formats. In lossless, there is no data that is discarded. So when we save an image in a lossless format, all the data for all the pixels is preserved. Where in the lossy formats, just the opposite. Data is discarded. And the reason for doing that is to make the file size smaller. For example, a lossy bitmap format commonly used is the JPEG. So when we scan something and it's saved as a JPEG, a tremendous amount, maybe 90% of the data is discarded. The image may still look good to us, and that's because with a JPEG, it does a very good job of throwing away those things that we're probably not going to notice. But it has thrown information away, and primarily again to make the file size smaller. So the lossy format is typically used in a final delivery form. So in other words, what I mean by that is we would do all of our editing in a lossless format. So we have access to all of the pixels and all of the data. And then once we're done with our editing, we would save a version in a lossy format, because maybe what we're doing is editing images going to go on a web page. Well, we don't want a real large image going on our web page. It takes longer to load. It takes up more space than it needs to be. So we'll save it as a JPEG. And that'll keep the file size very small, image still reasonably good looking, and works well then for that particular final delivery. So we always, when we want to preserve the data, save it as a lossless format, and then more than likely save it in some type of lossy format. Now, an example then for a lossless would be a TIFF. A TIFF is a lossless format in most situations. So is a bitmap. So if you're scanning and you're trying to save this in some form so you can work it on the image in Photoshop, your best bet is to choose one of these. While you're working in Photoshop and you get all done, you can save a version then as a JPEG. All right. Also, another reason we may never save it as a lossy is if we are going to print an image. And what I mean by print is that it's going to go to a printer or to a printing press or to a printer such as a print house where we got magazine and everything. They would want, the printer will need, in order to give you the maximum amount of detail in that image, they're going to want a lossless form. So the lossy is typically going to be for more of an on-screen type of display. In most cases, we're interested in keeping things very small. Whereas in the lossless, that's going to be for our editing and for printing. Now, you can certainly take images off of the internet that are JPEGs and print them out on your printer. But the best amount of detail, the most amount of detail you're going to get is if you have the image saved as a TIFF or a bitmap. All right, so that's a little bit about file formats, looking at the bitmapped versus the vector and the lossless versus the lossy.